Hi, my name is Glenn Conlon of Canon Technologies, and welcome to Rail SISS. Here we're demonstrating the latest S-type cabinet, which is for SISS applications. This particular product was developed for rail applications and would go station side or track side. It's developed around the S-type cabinet, which has been PADS approved and has a 3mm thick galvanised steel outer casing. And if I open the door, you can see inside of here the fact it is double skinned. This is to protect from protecting the electronics from rapid heat change. Rapid heat change can be caused, for example, by temperatures differences in ambient temperatures, as well as solar heat gain, obviously heat from the sun. We've developed this product with several different features, and we're going to go through some of those features. So standard, if you open actually the door, what you'll see is there's actually an LED light inside, an energy efficient LED light. This provides instant visibility for the service engineers when they're working on the cabinet, obviously important during night time. Some of the other additional features here, you can see bottom cable entry gland plates. These are removable to give you access to the ducts where the cables are entering through into the cabinet, and also access to bolting down the cabinet either to a concrete plinth or to the standard low concrete precast concrete bases. You can also see here a laptop computer. This laptop computer or a similar PC will be housed in the network operating center, and what you're able to do is remotely monitor what's going on within this cabinet, so that, for example, if it's placed at remote locations, remote stations, what you can do is actually you can see any faults that are occurring, or you can see if somebody's tried to enter the cabinet. And you can send back a message to your external field engineers really to go on site, and they can have an idea of what needs to be repaired and take the necessary spare parts so they don't have a wasted journey. So it can actually detect temperatures, humidity, it can give fault detection, so if a fan fails or if the temperature goes out of band, so above or below the temperature that you set on the software, it will send you an alarm message back, either by SMP or actually by a text message or an email. This is all done, as I said, remotely, and you get a live feedback to the network operating center, where they actually see the web-based software tool. Other things that are actually features is within this book is it's standard 19-inch rack mounted. You can use Etsy, or we could fit a backboard in there if you have electrical equipment, that type of thing. This particular version is a 30U high version, but we also have 25U or 33U versions. And as a manufacturer and a designer of indoor and outdoor enclosures, we can actually produce your product specifically to your specifications. So for example, if you needed a 42U high version, we can also do that as well. In this variant, you can see here there's an end pod. This end pod holds a lot of the electrical switchgear, the low voltage switchgear, as well as the thermal control system. We'll have a look at that just in a moment. So as I mentioned, this is the end pod which houses the LV electrical distribution, but also what you'll see is it's a second door. There is actually 3 doors on this enclosure, one to the front of the 19-inch and one to the rear, so it gives you perfect access to front and rear of the enclosure for maintenance and servicing. The lock system is a stainless steel. It's been SR3 approved, and we've worked with Network Rail to actually provide a very secure system. This variant houses the lock system where you can put a padlock on there, for example, but we also can fit the L221 key. There's also a lot of industry standard D-type barrels that can be fitted to this enclosure, as well as a remote electronic system. The remote system is accessed via the laptop or a PC from the network operating control system. So when an engineer goes to site, he can make a phone call and then he can actually request access, at which the lock will pop out once it's given access, and he'll be able to open the cabinet. So if we open the cabinet door, this variant is the fan version. You can see this is a 48-volt fan version, which you're able to control the fan speed so that they vary depending on the temperature inside the enclosure. This is important because what we want to do is control the temperature and make sure that we don't get any rapid changes in temperature within the enclosure. Rapid changes of temperature can cause problems to the electronics, and they can be damaged or they can fail very, very quickly. So as I say, this is the 48-volt van version. We've got a control chiller card system which controls the fans as well as provides all the monitoring, provides digital and dry contacts, as well as being able to control relays, things like that if you want to turn a heater on and off during winter time to make sure you maintain the right temperature inside the enclosure. The door itself here has got the filters in there for the ambient forced air cooling system, but we could quite easily change this to a heat exchanger or an air conditioning unit should it be necessary to bring the temperature below the ambient. Here we can see our network controller cards. These are the cards which are used to connect back to the network operating system. And here we've just got a small low voltage switching which includes a mains incoming switch, RCCD, residual current device, as well as various MCBs. Each of these MCBs obviously provides power and fusing connection to things like lighting, fans. We have fans in the roof of this cabinet also as a demonstration unit, as well as this forced air fan system which forces air to the front of the 19-inch area. Also we fit things like service sockets which could have their own RCD 2-gang sockets. These can be used for customers' service equipment and then they come to service the actual products, as well as doing things like plugging in their laptop so they can access any of the necessary diagnostic systems to ensure that the system is running healthily. Mains incomer here, you can see this is all installed by Canon Technologies. We have 17th, electrical 17th approvals, and all necessary certification comes with the cabinets as well. So this is the rear of the actual cabinet now, where we're providing access to the rear of the equipment. Here we're going to obviously operate the locking system. To explain the locking system, as I said, it's a stainless steel locking handle. You can have different barrel versions, including the L221 key, padlock version, and electronic remote locking system. And you can see here when we actually move the lever handle, it pushes down, up or down the lock rods, which actually go into the main chassis of the cabinet. This provides a good degree of protection on security. And we can have a third point where it can lock into the frame itself as well. Door lock stays here are as standard. It's important obviously because you get a lot of wind, a lot of forced air from trains passing trackside, etc. So that will go into place and be fixed by the engineer to ensure the door doesn't obviously flat back on the service engineer. Here you can see the mains heater. The heater, we actually do some calculations to work out the size of the heater that's required, and what we do is we take calculations about how much electronic equipment's fitted in there, how much heat is produced by that equipment, and then we calculate what is required, the difference to bring the cabinet up to temperature during minus temperatures. Again, you can see here another sensor which allows us to operate the door light, so you can light the cabin up and ensure you can see good access during servicing, etc. And down in the base there is the main earthing point where the contractor would bring in the main earth, which is then distributed between all of the different panel work, etc. So here we can actually see the top fan tray. This is controlled by mechanical electrical thermostats. These are a 230-volt system, but it provides additional cooling should it be required. And as I said, we set the thermostats to actually the set temperature so we can actually draw as much temperature out as possible. The actual fans are actually sucking the air and they're actually blowing it back out through the roof section here into slots, and you can actually feel a high degree of forced air coming out of there. So we're looking at probably cooling within 1.5 kilowatts, something like that, depending on the delta T and the ambient air temperature. But it does provide a high degree of cooling level. As I said, this is the actual heater, and we do some calculations to size the heater. Here we can actually see some of the bottom gate entry gland plate systems which are removable, and you can actually see the rubberized system which we use for different size cables, and these are actually modular systems, so we can actually remove and change them depending on the size of cable which is actually entering in through the base of the cabinet. Also what you can see here is the base plinth. As I said, earlier, this can either be mounted on a galvanised base plinth, or it can be mounted on the half or the full width precast concrete loke, which is the Network Rail standard. So when we're installing the cabinet, we need to lift the cabinet into place, and here we can see two of the removable lifting eyes. These will take the necessary weight of the actual particular cabinet and a weight stamped to ensure obviously compliance with the necessary health and safety standards. We can also lift from the main plinth of the cabinet as well, and there are removable lifting eyes able to be placed in that section as well, if you want to lift it from the base or lift it from the top, or both.